Good evening, dear students. Yes, so in the last class, we have seen the chemical properties, right? Chemical reactions of amines. So different chemical properties, reactions we have seen of amines. Okay. So as we have discussed yesterday, we are going to start today about diazonium salts. Okay. So we are going to discuss about what? We are going to discuss about diazonium salt. So let me go. Okay. So what are diazonium salt? Yes, what are diazonium salt? So R N2 plus X minus, right? So this is the general representation of the diazonium salt, where R is your alkyl or the aryl group. Okay, then N2 plus is what? It is a diazonium group, and X minus is the halide group, right? So let us discuss about the nomenclature. Nomenclature means what? How to name the compounds. Okay, how to name the compounds we are going to discuss, okay, in the diazonium salts. So diazonium salts, okay. So nomenclature, so these are the salts, okay, they are named by, you can put the suffix to it, that is diazonium to the name of the parent hydrocarbon. So if the name of the compound, suppose I have this benzene, okay, suppose I have this compound of your diazonium salt, that is R. So here what I've taken R, I have taken a phenyl ring. Okay, I have taken a aromatic benzene ring. So what is the name now? So now this is a benzene ring, right? So this is our hydrocarbon, that is a benzene. So this is benzene diazonium. So we are going to put the suffix. Okay, suffix means what? The word which we put at the end. Okay, so benzene diazonium, and which is the halide, it is chloride. So it is benzene diazonium chloride. Okay, one more example. If I give you, take one more example. So I'll take like this, and N2 plus HSO4 minus. Okay, so what is the name now here? So again, benzene. Okay, what is the suffix? The suffix is diazonium. Okay, the suffix is diazonium and hydrogen sulfate. Okay, and hydrogen sulfate. So like this, we are going to name this diazonium compounds. Okay, so whenever we are naming the salts of these diazonium, so the diazonium is the word which has to be added at the end of the compound. Okay, so that is the suffix we are going to add as diazonium. Okay, so the primary aromatic amines. Okay, whenever you have primary aromatic amines, so if you have primary aromatic amines, suppose which is the best example of a primary aromatic amines, your aniline. Okay, if I take a aniline as a primary aromatic amine, so what they will form? They will form arene diazonium salts. Okay, they'll form what? Arene diazonium salt. So when we take the starting product as a primary aromatic amine, suppose aniline, we are going to get a arene diazonium salt. Okay, and these are stable at room temperature. Okay, sorry, at low temperature. So these arene diazonium salt, they are stable at what temperature? At a low temperature. We have seen this, right? Condition. So the condition is that whenever we have a primary aromatic amine, so these can be converted into arene diazonium salt, and these are stable at room temperature. Okay. While whenever you have a primary aliphatic amine, okay, whenever you have a primary aliphatic amines, okay, what they are going to form? They are going to form the unstable, okay, they are going to form unstable alkyl diazonium salt. Okay, so they are going to form alkyl diazonium salt. So these are unstable. Okay, these are unstable. So whenever you have aliphatic, which is the example of aliphatic? Suppose I take it as methylamine. Okay, I'll take methylamine, ethylamine. So these are the example of aliphatic amine. So when they are converted into the aliphatic amines, okay, arene diazonium salt, they will form unstable alkyl diazonium salt. Okay, and these are unstable. So why it is stable? Okay, why the primary aromatic amines they form stable arene diazonium this salts? Because of the resonating structures. So when you see the resonating structures of the benzene compounds, we have the benzene, right? So how it is represented? So N plus, okay, N plus, this is minus. So because of the conjugated system, because of the presence of the benzene ring, you can see the charge, okay, the charges on the arene, that is your diazonium group, it is stabilized. Okay, so it is stabilized. So it can be what? So this can uh, it will undergo the resonating structure. So they will show what? They'll show the resonating structure. So because of the resonating structures, okay, the arene compounds they are stable. Okay, they are stable. So these are stable. So if I write the what you say, the your resonating structures. Okay, so this is plus double bond N, so double bond minus, so this is plus. Okay, so here again the charge we are going to, the positive charge is overall it is rotated. Okay, it is balanced. So it is balanced N plus N minus. So what is happening here? The charge, it is going to, so these are the resonating structures. So because whenever you have arene compounds, what will happen? The charge will be stabilized. So because the stability of the arene diazonium compound, why? Because of the resonating structure. So because of these structures, the arene diazonium salts, they are stable. Okay, they are stable. Okay. So this can be a question. Why arene diazonium salts are stable? Okay. Then you have to explain with the resonating structures. Okay. So primary aromatic amines, they form stable arene diazonium salts because they form a stable arene diazonium salt because they undergo resonating structures. Okay. Okay. So this is the reason for that. Okay. So this is the important thing, so that you have to remember. So whenever you have primary aromatic amines, they will form stable diazonium salt. And whenever you aliphatic amines, you have unstable alkyl diazonium salt. Okay. Next, we are going to discuss the methods of preparation. Okay, we are going to discuss the methods of preparation. How we are going to prepare the compounds. Okay, how we are going to prepare the diazonium salts. Okay. So next is what? We are going to discuss the methods of preparation of diazonium salt. So first is the important reaction, that is diazotization. Okay, diazotization. Okay, diazotization. So diazotization reaction. So very important. Mark this as important, students. Okay. So this is very important from exam point of view. Diazotization reaction. So what is the reaction? So we have seen this reaction. One more time we are going to see. So we are going to take what? Our starting product is aniline. Okay. We are going to take what? Aniline. So primary aromatic amine. So this is our aniline. So this we are going to treat it with what? Sodium nitrate. Sodium nitrate plus HCl will give you what? It will give you nitrous acid. Okay, it will give you what? Nitrous acid. So primary aromatic ring, that is amine, primary aromatic amine, when it reacts with NaNO2, that is sodium nitrate and your hydrochloric acid. Okay, we are going to get nitrous acid. What we are going to get? Nitrous acid. And what is the important? That is the condition is important. It should be 0 to 5 degrees Celsius, or it should be 273 to 278 Kelvin in Kelvin. Okay. So the temperature condition is very important. That is, it should be a very low temperature should be maintained. So what we are going to get? We are going to get a benzene diazonium, okay, N2 plus Cl minus. So what we are going to get? We are going to get benzene diazonium chloride. What we are going to get? Benzene diazonium chloride. Okay, plus NaCl plus 2H2O. So here what we are going to do, so this is the diazotization reaction. So primary aromatic amine, we are going to react it with what? The mixture of sodium nitrate, okay, the mixture of sodium nitrite and your hydrochloric acid, okay, hydrochloric acid at a temperature condition of 0 to 5 degrees Celsius, that is at a low temperature. Okay, we are going to get what? Benzene diazonium chloride, okay, or benzene diazonium salts. So this is the diazotization reaction. Is it clear? Very important. Mark this important, students. Important. Mark this important. Okay. So this is the one important method of preparation of diazonium salts. Next, we are going to see the chemical reactions. Next, we are going to see what? Chemical reactions. Okay, next we are going to see the chemical reaction. So here, the chemical reactions of diazonium salts, they are categorized into two types. Okay, so the chemical reactions, they are categorized into two types. The first one is reactions involving displacement of nitrogen. Okay, displacement of nitrogen. And second one is reactions involving retention of nitrogen. Okay, retention of diazo group. Okay, so these are the two types of reaction which we are going to see. First one is reaction which is involving the replacement of nitrogen. Okay, we have to replace or we have to displace the nitrogen. And second one is we are going to retain the diazonia group. So let us start with the first one. Let us start with the first one. So reactions which are involving the displacement of nitrogen. So what is happening in this? In this type of reaction, we have the nitrogen. Now nitrogen, okay, whenever I have a sorry, I'll take a diazonium salt. How we are going to take? We are going to take R N2 plus X minus, right? So here, this, where is our nitrogen? In the diazo group, right? So the in this reaction, the diazo group, so that is your diazo group is N2 plus. It is replaced by what? We are going to replace this particular group by a nucleophile. Okay, we are going to replace the diazo group by a nucleophile, and whatever our nitrogen gas is there, okay, so nitrogen gas will be evolved. So the N2 plus, okay, N2 plus, that is our diazo group, will be converted into the nitrogen gas. Okay, it is going to convert into. Okay, fine. So next we are going to see the replacement by a. So replacement by halide ion or cyanide ion. Okay. So we are going to take nucleophile. Which particular nucleophile? We are either going to take a halide ion, that is X minus, or we are going to take a cyanide. Okay. So here, so which are the different reaction it will undergo? So let me take as the. So AR means our aromatic ring. Okay, AR means what? Aromatic ring. AR means what? We have a aromatic ring. So AR N2 plus X minus. Okay. So this, if I if I treat it with your cuprous chloride, Cu2Cl2 in the presence of HCl, I'm going to get what? I'm going to get ArCl. So our N2 group. So what we are going to do? Our diazo group is present. Okay. So this diazo group we are going to convert into a nucleophile, and whatever our diazo group is there, that will be evolved as what? As a nitrogen gas. So this is the reaction. So this is the first reaction like this. So if I take Cu2Br2 and HBr, okay, what will be the product? If I take CuCN minus N KCN, can anybody tell me second product? What will I get the second product? What I'm going to do? This group, okay, our N2 plus group, that is our diazo group. I am going to convert it into what? I'm going to convert it into the nucleophile. Okay, I'm going to displace it by a nucleophile. So which nucleophile? Either I'm going to take halide, which is the halide here Cl minus, here Br minus, and here Cn minus. Can you tell me the product for second one? Yes, Ar Br plus N2. Very good. Okay, so it is Ar Br plus N2 gas is evolved. Very good. Then second one, third one. If I treat our this ArCN. Yes, very good. So it is ArCN plus N2. So what is this compounds? Yes, very good. Okay. So here, so this is a chlorobenzene. So this is a chlorobenzene. This is bromobenzene. Okay, this is bromobenzene. How we are going to see here? Ar means what? Like this. Okay. ArCl. Then this is Br. Then this is Cn plus N2 plus N2 plus N2 like this. Okay. So this is what? Cyanobenzene. Cyanobenzene. Now here, this is a very important reaction. So the diazo group, okay, when the diazo group is replaced by chloride, bromide, or cyanide ion in the presence of Cu1 ion. Okay. This reaction is called as what? This is called as Sand-Meyer's reaction. Okay, it is called as what? So a Sand-Meyer's reaction. Very important. Mark this important. So whenever we are converting our diazo group, okay, N2 group by chloride ion or bromide ion or cyanide ion, we are going to get, okay, the type of reaction, and this type of reaction is called as Sand-Meyer's reaction. Please mark this important. What is Sand-Meyer's reaction? What we are doing? We are converting our diazo group. Okay, we are converting or we are replacing our diazo group by chloride ion or bromide ion or cyanide ion. So this name reaction is called as what? This is called as what? Sand-Meyer's reaction. Is it clear? Okay, so another name reaction which is Gatterman reaction. Okay, another name reaction which is the Gatterman name reaction. So just now what we have seen is Sandmeyer's reaction. Okay. So what we have done, we have in Sandmeyer's reaction, what we have done, we have replaced. Okay, we have replaced our diazo group by chloride ion or bromide ion or cyanide ion. Okay. So this type of name reaction is called as what? Sandmeyer's reaction. Now, what is Gattermann name reaction? Here also we are going to convert our diazo group. Okay. We are going to convert our diazo group into corresponding benzene, that is our chlorobenzene halide, okay, or bromobenzene. But here what we are going to introduce, we are introducing the a nucleophile, that is chloride ion or bromide ion in the benzene ring. How? By treating our benzene diazonium salt with a halogen acid. So what we are going to take? We are going to take a halogen acid, okay, in the presence of a copper powder. So what is important here? Copper powder is important. So if there is a copper powder and respective halogen acid, if I take hydrochloric acid, I'm going to get chlorobenzene. Okay. If I take this what which is that HBr. Okay. Hydrogen bromide. Okay. So this particular, if I take in the presence of a copper powder, I'm going to get what? Bromobenzene. Okay, I'm going to get bromobenzene. So this is name reaction is called as Gattermann reaction. So whenever we are introducing Cl or Br, okay, on directly on the benzene ring, when we are treating the benzene diazonium salt with halogen acid in the presence of copper powder, this name reaction is called as what? Gattermann reaction. What it is called as? Gattermann reaction. Very important. Okay. Uh, Gattermann reaction and Sandmeyer's reaction. So these are the two important name reaction. Is it clear? Yes. Okay. So what is okay? So okay, let me again explain you about Gattermann reaction. Okay. Uh, So here what we are going to do, we are going to take us here, don't get confused. AR is nothing but benzene ring. Okay, benzene ring N2 plus Cl X minus. Okay, now X minus can be your, what I'm going to take, so this is what? Our diazonium, benzene diazonium salt. This is our benzene diazonium salt. Okay, now this benzene diazonium salt, I am going to do what with Gattermann reaction? What is the reaction? Gattermann reaction. In Gattermann reaction, I'm going to directly introduce, if I want to directly introduce Cl minus, what I'm going to take? I should take the corresponding halogen acid and I have to take the copper powder. Okay, so if I take copper powder with the halogen acid, what I'm going to get? What I'm going to get? I'm going to get Cl. Okay, N2 is here. So let me take it this side only. So it is Cl. Okay, so I'm going to get Cl plus N2 plus Cu Cl. Okay, CuCl like this. So like this, I'm going to get. So this is our what? This is our chlorobenzene. So this is our chlorobenzene. So this is when I want to introduce the Cl minus at the benzene diazonium salt. So how I'm going to convert? I'm going to take the halogen acid in the presence of the copper powder. Okay. Now same way, if I want to introduce Br minus. Okay. So what corresponding halogen acid I should take? I should take HBr in the presence of copper powder. Okay. Copper powder is important in Gattermann reaction. What I'm going to get? Br plus N2 gas, Cu, Br. Okay, is it clear? Now is it clear? Is it clear, Shrivarune? Any doubts? Any other doubts? Now this is about Gatterman. Okay, now let me explain you here only about Sandmeyer's if you are getting confused. In Sandmeyer's reaction, what we are doing? Okay, here also we are taking what we are taking N2 plus X minus. Okay, so again we are taking benzene diazonium salt. Okay, let me take it as BDS. Now here what we are going to do, we are either going to take Cl minus. So here this is in the presence of, if I want to introduce Cl minus, so I have to take Cu2Cl2 in the presence of HCl. What I am going to get? I am going to get Cl plus N2. Okay. Here our diazo group is converted into nitrogen gas. If I want to take Br minus, so Cu2Br2 in the presence of HBr, what I'm going to get? Br plus N2 gas. Okay. If I want to introduce cyanide, okay, so it is CuCN in the presence of KCN. What I'm going to get? Cn, okay, plus N2. So this is Sandmeyer's reaction. So directly on the diazo group, when I want to replace by Cl minus, Br minus, or Cn minus, okay, in the presence of Cu in the one state. So our copper is in what state? Our copper is in +1 state. So here in the all cases, you can see there is a copper which is in +1 state. So we are going to get, so this is our Sandmeyer and this is our Gatterman name reaction. So two important name reaction, very important. So please remember this, mark it as important for 2 marks. Okay. So this was the two reactions. Now next is what? Next is we are going to replace, so replacement by iodide. So what we saw, we saw two halides. We have seen how to replace the diazo group by Cl minus as well as Br minus. Now we are going to see by I minus. Okay. So what we are going to do, again, we are going to take a benzene diazonium chloride, or we are going to take benzene diazonium salt. Okay, I'm going to treat it with potassium iodide. Okay, I'm going to treat it with potassium iodide. What I'm going to get? I am going to get a idobenzene. Okay, I'm going to get what? Idobenzene plus N2 gas is liberated plus Ki. Okay, plus Ki. So this is our idobenzene. Understood? So how to replace the diazo group by iodide? So by reacting it with potassium iodide. So when benzene diazonium salt is reacted with potassium iodide, we obtain iodobenzene. Okay, iodobenzene is obtained. Is it clear? Is it clear? So we have seen how to replace the diazo group by Cl minus, Br minus, and I minus, iodide. Now we are going to see by F minus. Okay. So the third one is by replacement by fluoride ion. Okay, replacement by fluoride ion, that is F minus. Okay. So again, what I'm going to take? I'm going to take a benzene diazonium chloride. Benzene diazonium salt. Okay, benzene diazonium salt. I'm going to treat it with fluoroboric acid, that is HBF4. What it is? Fluoroboric acid. What it is? Fluoroboric acid. What I am going to obtain, students? What I am going to obtain? I'm going to obtain what? I'm going to obtain N2 plus and BF4 minus. Okay, N2 plus. So what is happening in the first step? Our X minus is replaced by BF4 minus. Okay, then I'm going to heat it. Then I'm going to what? I'm going to heat it. After heating, I have to get the fluorobenzene. I'm going to get fluorobenzene plus nitrogen gas is liberated plus BF3. Okay, plus BF3. So here what we are going to get? So when diazonium chloride, diazonium salt is treated with fluoroboric acid, okay, it forms diazonium fluoroborate. What it forms? Diazonium fluoroborate. Okay, it forms what? Diazonium fluoroborate. And this diazonium fluoroborate, what we are doing? We are going to heat it further. What we are doing here? We are going to further heat it. Okay, after heating, what it will become? It will decompose, right? After heating, what will happen to the reaction? It will start getting decomposed. So after getting decomposed, what we are going to yield? We are going to yield fluorobenzene. Okay, we are going to yield fluorobenzene. Okay, so this reaction is called as Bals-Schiemann reaction. Very important name reaction. One more, Bals-Schiemann reaction. Okay, mark this as important. So we have seen three name reactions here in diazonium salts. Very important. Okay. Sandmeyer's, Gattermann, and Bals-Schiemann reaction. Okay. So these are the three important name reactions. So these can be asked for 2 marks each. Okay. So remember these particular this. Okay. So is it clear? Understood about how to, so we have seen about iodine as well as fluoride also, how to replace, okay, how we can replace the diazo group by iodide as well as fluoride ion. Is it clear? Okay, let us go for the next one. Next is replacement by hydrogen. Hydrogen means what? When we are adding hydrogen means we are doing reduction, right? We know this. So when we are adding hydrogen, that means we are doing reduction. So again, we are going to take benzene diazonium chloride, okay, N2 plus Cl minus. So this is what? Benzene diazonium chloride. Okay. This I'm going to treat it with what? I'm going to treat it with hypophosphorus acid, H3PO2. Okay. It is hypophosphorus acid in the presence of water. Okay. What we are going to get? I'm going to get okay. So we get arenes. We get back what? We get arenes. We get back our benzene. We get back our benzene plus N2 gas is liberated plus H3PO3 plus HCl plus HCl. Okay. So if I take one example, one more example I can give you. So again, benzene diazonium chloride. Okay, if I treat it with ethanol. Okay, so if I take ethyl alcohol, if I react it with ethyl alcohol, okay, either you can take hypophosphorus acid, you can do reduction with hypophosphorus acid, or you can take ethanol. Okay, or it can be possible with hypophosphorus acid or ethanol. So what I'm going to get? I'm going to get a benzene. I'm going to get what? I'm going to get benzene. So no need to write arene. So let us write benzene only. Then you'll, okay, benzene plus N2 plus acetaldehyde plus HCl. So this is the replacement reaction. So we are replacing our diazo group by what? We are replacing our diazo group by hydrogen. Okay. We are replacing our diazo group by what? Hydrogen. Is it clear? So what we are doing here? We are doing the replacement reaction. We are doing the replacement reaction. That is, we are replacing our diazo group. Okay. Our N2. What we have seen? We are seeing two type of chemical reaction. First one is displacement of diazo group. Right. So we are displacing the diazo group in different reaction. So here what we are going to do, we are replacing the diazo group with the hydrogen. So we are going to yield the benzene. Okay. Either you can take hypophosphorus acid or you can take ethanol. Okay. Is it clear up to here? Is it clear? Any doubts? Yes, any doubts? If you find any difficulty, you can ask me at any point. Okay, fine. So next one is we are replacement of hydroxyl group. Okay, replacement by, not of, replacement of diazo group by hydroxyl group. What is hydroxyl group? OH minus. Okay, OH minus is the hydroxyl. Again, let us take benzene diazonium chloride N2 plus Cl minus. So this is our benzene diazonium chloride. So benzene diazonium chloride, we are going to treat it with water. Okay, we are going to treat it with aqueous solution, and okay, we are going to warm it at 283 Kelvin. Okay, at 283 Kelvin, what we are going to get? We are going to get a phenol. What we are going to get? We are going to get a phenol. Okay, phenol plus N2 gas is liberated plus HCl. Okay, phenol plus N2 gas is liberated plus HCl. Okay, so this is what we are doing again. We are replacing our diazo group by a OH group. That is our hydroxyl group. So what we are doing? We are treating our diazonium salt with aqueous solution. We are going to warm it. We are going to warm it. Okay, and we are going to get phenol. We are going to get phenol. Next one is replacement by nitro group. Replacement by a nitro group. So let me write the reaction. So again, benzene diazonium chloride N2 plus Cl minus. I'm going to treat it with what? Fluoroborate. Okay, we are going to treat it with fluoroborate. That is fluoroboric acid. We are going to treat it with what? Fluoroboric acid. What I'm going to get after treating it with fluoroboric acid? I am going to get what? I'm going to get a intermediate, that is N2 plus BF4 minus. I'm going to get what? I'm going to get diazonium fluoroborate. I'm going to get diazonium fluoroborate. Okay, fluoroborate. This further, I'm going to heat it with NaNO2 in the presence of copper. Okay, and I'm going to get nitrate. What I'm going to get? I'm going to get nitrate. Okay, nitrobenzene plus N2 plus NaBF4. Okay, so this is the reaction. So what we are doing again in this reaction, we are converting our diazo group by a nitro group. So what we are doing here, first step is what? We have taken benzene diazonium chloride. We have taken benzene diazonium chloride. Okay, benzonium chloride. I have treated with what? Fluoroboric acid, HBF4. Okay, what I'm going to get? Our Cl minus is replaced by BF4. Okay, our Cl minus is replaced by BF4 minus. So I get benzene diazonium fluoroborate. This diazonium fluoroborate, I'm going to treat it with sodium nitrate in the presence of copper. Okay, I'm going to heat it. I'm going to get nitrobenzene plus N2 gas is liberated plus sodium borofluorate. Okay, so this is the reaction. Okay, this is the reaction. So these are the 6 replacement reactions. So which all we have seen? So we have seen replacement of first one, that is Sandmeier's reaction. Then we have seen Gattermann reaction. Then we have seen replacement by iodide ion. Then replacement by fluoride ion. Replacement by hydrogen. Replacement by hydroxyl ion. Hydroxyl group, and replacement by nitro group. So these are the 6 replacements. Any doubts up to here? So these are the 6 replacements. Okay. So replacements reaction. So what we are doing? We are converting, or we are replacing our what we are replacing? Our diazo group, that is N2 plus group. Okay, N2 plus 2 by respective halide, either chloride ion, bromide ion. Okay, then what we have seen, fluoride ion, iodide ion, hydrogen, then hydroxyl, and nitro group 1, 2, 3, 4, 5, 6, 7. Okay, so this was under one. So these are the different reactions. Okay, these are the different reactions. Fine. So is it clear? Okay. So this completes the first type of reaction. Second one is retention of diazo group. So now we are going to keep the diazo group. Retention means what? We are keeping the diazo group. So retention involving, second one, retention involving reactions, sorry, not retention, reactions involving retention of diazo group. Okay, so this is called as coupling reaction. This is called as what? Coupling reaction. Mark this as important. Mark this important, very important, very important. Okay, so here what we are going to do. First, I'm going to take a benzene diazonium chloride. Okay, I'm going to take what? Benzene diazonium chloride. So all the reactions are of benzene chloride. So I require a benzene diazonium chloride. So this is our benzene diazonium chloride. Okay, so instead of writing N2Cl, I'm going to write N plus, okay, like this. So instead of writing N2 plus Cl minus, I have written like this. Okay, don't get confused. So like this. So it is benzene diazonium chloride. This benzene diazonium chloride, I'm going to react it with phenol. I'm going to react it with what? Phenol. Okay. Now, the diazonium salt, okay, it is going to react with aromatic compounds like phenol. What I'm going to get? I'm going to get a coupling reaction. Okay, I'm going to get a coupled reaction. So, I'm going to get N, double bond N. Okay, and this will go and attach this ring, and we are going to get OH. So this is a coupling reaction. So this is a compound called as para-hydroxy azobenzene. We get a azo compounds here. Okay, plus Cl minus plus H2O. So this color will be a orange dye. Okay, the color of this complex is orange color. Okay, it is orange dye. So what we are going to do, we are going to take benzene diazonium chloride. Okay, we are going to react it with a compound like phenol. Okay, and we are going to take what? We are going to take this solution in the cold condition. Okay, cold condition is there, cold condition. Now in this cold condition, it forms what? A azo compound, that is a bright colored dye, which is called as the azo dye. And this reaction is called as a coupling reaction. And this is an example of what? You can say this is an example of a electrophilic substitution reaction. Okay, so this is an example of electrophilic substitution reaction. Remember this, don't forget it. So what we are going to do, so here we have kept the N2 group, right? Whatever N2 group is there, we have retained it, right? We have retained it, we have not replaced it. So this is another important reaction, which is a coupling reaction. So we have taken benzene diazonium chloride and we have taken phenol. Okay, in the cold condition, it forms a bright orange compound or azo dye, which is a orange dye. And this reaction is called as a coupling reaction. And this is a electrophilic substitution reaction. Okay, so very important, write it down. So this is with phenol. So same way it can undergo reaction with aniline. Can you write the reaction and just try? Okay, write this reaction, para-hydroxyazobenzene. So both these are So it can, your benzene diazonium chloride can react with phenol, okay, or it can react with aniline. Now we have seen with phenol, now we will see with aniline. So again, I'll write benzene diazonium chloride N plus Cl minus, okay, plus aniline is what? NH2. Okay, so this is aniline, this is benzene diazonium chloride. Okay, so H plus. So what I'm going to get? So this is the electrophilic group. Okay, so this is the electrophilic group here. So this will go and attach there. So what I'm going to get? So benzene ring N double bond N. Okay, and I'm going to get this group will go and attach here. Okay, and I'm going to get Cl minus plus H2O. So this is a para amino azobenzene, para-amino azobenzene. And this is yellow color dye. This is a yellow color dye. Okay, and that was orange color dye. So with phenol, you get orange dye. With aniline, you get a yellow dye. So these are azo compounds. Azo compounds. Okay, is it clear? Is it clear both the coupling reactions? So what we are doing here, we are retaining. Retaining means what? We are keeping. Okay, we are retaining the azo group. We are retaining. We are not discarding it. Okay, we are keeping the azo group. So this is the what? This is your uh, this compounds. Okay, so we have seen two azo compounds. If we treat it with phenol, okay, when you have your benzene diazonium chlorides, when it reacts with phenol, you get a orange dye. When it reacts with aniline, you get a yellow dye. And these both are azo compounds. Okay, there is a retention of diazo group. Okay, fine. So let us see the last part. What are the importance? Okay, what are the importance of this diazonium salts in synthetic organic compounds? So diazonium salts, these are the good intermediate for the introduction of your F minus, Cl minus, Br minus, iodide ion, Cl minus, OH minus, NO2 group, okay, into the aromatic group. So these different groups can be introduced, okay, into the aromatic ring. So by using the diazonium salts. Okay, so if you use the diazonium salts, what you can get? You can get any aromatic substituted compound, right? Your X can be F minus Cl, Br, I, or it can be CnOH, NO2. So any aromatic substituted group you will get. So it is a good intermediate. Your diazo compounds are good intermediate. What do you mean by intermediate? Intermediate means the in-between product, right? It is a good intermediate. So this is the first point. Second point is whenever you have these diazo compounds. So we have seen the diazo compounds, they are used in the preparations of different azidides, right? In the different azo compounds, these diazonium compounds are, diazonium salts are used. Okay. Then whenever we are doing aryl fluorides or iodides, so aryl fluorides and iodides, they cannot be prepared by direct halogenation. Okay, but so if you want to do aromatic, if I want to get a iodobenzene or I have to get a fluorobenzene, so by directly halogenation, by directly doing the corresponding halogenation, we do not get direct compound. But by using the intermediate, that is your diazo salt, we can obtain these particular aryl compounds. Okay, so these are the importance of diazonium salts. So this much is there for your syllabus about the diazonium salt. Okay. So these are the important things which are to be covered in the diazonium compound. Any doubts up to your? Oh. So this completes your chapter amines. Okay. So in the amine chapter, so did I tell you The weightage of amines chapter. So this particular amines chapter, okay, it is a very small chapter, but the weightage is 8 marks. Okay. Okay, the weightage for this particular amines chapter is 8 marks. It is for 8 marks. Okay. So, so very small chapter, but very important chapter. Okay. So the concepts are short and important. So diazonium salt, any doubts in today's class or anything you have to ask from the chapter amines, you can ask me. Okay. Supriya, Shri Varuni does not have any doubts. Okay. So please go through the things. Okay. I think amines chapter I have to upload or I have uploaded. I will check. Okay. So let me. Okay, fine. No doubt. So please go through the notes. If I'll see. Okay. Yeah, we are working on the tests. Okay, soon it will be intimated for you all. Fine. Uh, okay. So I'll see if the notes are uploaded. You all also go through the things, okay, whatever I have been told. So Monday I'm going to start with the last chapter, that is biomolecules. Okay. So before coming to the class, please go through the chapter biomolecules. So in biomolecules, we are going to study about different biomolecules like carbohydrates, vitamins, hormones. Okay. So all these things, enzymes, then we are going to study about nucleic acid. So these all things we are going to discuss. So please go through the things, and Monday we will continue on the particular chapter, biomolecules. Okay. So please go through this amines. So I'll see if the notes are not uploaded, I'll upload them. Okay. And if you have any doubts, you can come back on Monday and you can ask me the doubts. Fine. Okay, fine. It is there. Okay, fine. So please go through the notes. Okay. Okay, fine. So I'll end the session here. Okay. So we'll meet on Monday. So Monday I'll start with a new chapter. So please go through the things, whatever I have told. Fine. So thank you. Have a good weekend.